Let us enjoy the journey of learning trigonometry with Anil Kumar. I am Anil Kumar. Welcome to our playlist. Here we have thousands of videos for you. In this particular video, we are going to discuss trigonometry basics that will help you to have a great foundation. We are going to cover the five topics. We're looking into the right triangle, review the properties. Then we'll define the primary trigonometric ratios, which is sine, cosine, and tangent. Apply TOA in the given triangle. We'll discuss special triangles and then find ratio for a given point in the coordinate plane. So with that, we cover in-depth basic foundation about trigonometric ratios. I hope you will understand and enjoy this journey. Follow our playlist for practicing related questions and adding on to your skills in trigonometry. Let's begin with the right angle triangle. As you can see, a triangle in blue with right angle at one corner. Let's label this triangle as ABC. Let's first understand what is a right angle triangle. So it has got three vertices A, B, and C, where one of the vertex makes 90 degrees angle. In this particular case, the vertex at C makes 90 degrees angle. Normally, we label lowercase a for side opposite to capital A, lowercase b for side opposite to B, and lowercase c for side opposite to the 90 degrees. And in Pythagorean theorem, you learn how are they related. The sum of squares of two smaller sides, a square plus b square, is equal to c square. Now that really helps us to find the third side if two are given to us, right? Now you also see the angles. How do we find the angles and how do we relate them with the side is what we are going to learn in trigonometry. So the angle A, which we have here, plus angle B, plus the angle C, the three angles in a triangle should always be 180 degrees, right? However, we know that angle C is 90 degrees, and therefore, what should be the sum of A and B? Well, C is 90, and that means the sum of A and B should be equal to 180 minus 90. That means 90 degrees, correct? So A plus B is 90 degrees. We could always write angle A as equal to 90 minus angle B in any right angle triangle. We can also write that angle B is 90 minus angle A, right? So that is how the angles are related in a given right angle triangle. So we saw these six things, three vertices and three angles. How are they related? Now where does the trigonometry comes in? We'll discuss this trigonometry right now. So we label the vertices as A, B, and C, where C was the right angle, and the side opposite will be lowercase a, b, and c, as shown here. Primary trigonometric ratios, we have three of them. One is called sine, the other one is called cosine, and we have tangent. These three are primary trigonometric ratios. There are other three also which are reciprocal and are called secondary trigonometric ratios. Now, sine, cosine, and tangent. Sine of what? Sine of an angle. So let's consider the angle A for now. So we'll write this as sine of lowercase a, the angle A. Now sine ratio is defined as ratio of opposite side to hypotenuse. As you can see, if you look from A, opposite side means what? Side opposite to angle A is A. Do you see that? So this is equal to A, the opposite side, and hypotenuse is the longest side, which is C, right? So this is called hypotenuse. Now you can always see that sine A cannot be greater than 1, right? Because A is always smaller than C, right? In a right angle triangle. Now let's find what is cosine of A. Cos A is defined as adjacent side over hypotenuse. So adjacent to A is this side. Between 90 degrees and the angle, and the length in this case is B, so we could write this as B over C. Make sense? So that is how we define our primary trigonometric ratios sine and cosine. And last one, which I am going to discuss, is the tan A. Tangent A is a full form, which is opposite over adjacent, which in this case opposite side is A and adjacent is B. You see that. So that ratio is called tan A. From here, it is important to also notice that tan A is also ratio of sine A over cos A. You can actually derive this, right? So I can leave that as an exercise for you for now, right? How is tan A equals to sine A over cos A? You can use the identities in a form, ratios which you just figured out, and work this out. Now tan A equals to sine A over cos A is also known as quotient identity. Well, actually, when we talk about trigonometric identities, we'll begin from here. But here, at this stage, you can see that tan A is sine A over cos A. Take it as a test question for now. How is it, right? Let's move forward. We have understood the right triangle and see what these ratios are, right? So we just said sine is ratio of opposite over hypotenuse. So we can write sine is ratio of opposite over hypotenuse. Do you see that? Cosine is ratio of adjacent over hypotenuse, right? And tan is ratio of adjacent opposite over adjacent. Correct. So we kind of get this acronym which is called SOHCAH-TOA, which we are going to explore further. So here we have written you a acronym where this SOH means sine of any angle, let's say sine of angle A, will be opposite, O for opposite, right? Over H for hypotenuse. Is that clear to you? This CAH is cos of A is adjacent over hypotenuse. And then we have this tangent ratio. We write tan of A, all are lowercase, opposite over hypotenuse. So if you are looking from the angle A, right, in a right angle triangle, then this is the opposite side, this is adjacent, and this is hypotenuse. Is that clear to you, right? So that is how we actually define these three primary trigonometric ratios: sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over hypotenuse. Is that clear to you, right? Now we can take up an example to find the ratios, right? So what we'll do is we'll just take up a point and we'll consider a triangle. So what I will do here is discuss with you special triangle. The triangle given to us is kind of special since one angle is 90, the others are 45 degrees each. Now, in this particular triangle ABC, we see that the angles are equal, right? That means it is an isosceles triangle. Correct? If one of the sides is x, the other will be x, right? Since the sides are equal. What will be AB? So A to B will be from Pythagorean theorem x square plus x square square root, right? Since we know the sum of squares is exactly equal to the hypotenuse square, right? You could have written like this also. We can write this as AB square, which is the hypotenuse, is equal to AC square plus CB square. Or we can say that AB square is equal to, we are taking them as x, right? Makes sense? Which is 2x square. So that means AB should be equals to square root of 2x square, which is x times square root 2. So the third side has to be x times square root 2. Perfect. Now, in this particular triangle, we can use SOH and find what is sine of 45 degrees. Angle A is given to us as 45 degrees, which is also equal to angle B. So, what is equal to sine of 45 degrees? Sine of 45 degrees, opposite side is x divided by hypotenuse, which is x square root 2. X cancel, we get 1 over square root 2. Makes sense. Well, sometimes we rationalize and rewrite this as square root 2 over 2. Perfect. Multiplying both numerator and denominator by square root 2. We rationalize. Great. Now, what is cos 45? Cos 45 degrees is also x, which is also the adjacent side, right, over the hypotenuse. So that is x square root 2. So, in this particular case, we see that sine and cosine 45 are exactly same. It was expected since this is an isosceles triangle, opposite side and adjacent side are of same length, right? So what should be tan of 45? Tan of 45 will be opposite side over adjacent, which is x over x, which is 1. So tan of 45 is 1. Perfect. So in a special triangle, you see sine ratios, cosine ratios are equal, which are square root 2 over 2, and the tan ratio is equal to 1. Now let's take another special triangle, which is having 60 degrees in a right angle triangle. If one angle is 60, how much will be the other? Well, the other has to be 30 degrees because the other two should add up to 90, right? 60 plus 30 is 90. Okay. Now, in this case, can you tell me what should be sine of 60 degrees? Now, to find this, let's consider a right angle, a equilateral triangle. So, I'm going to extend this, okay? If I extend it so that it is a 60 degrees each, then each side will be of equal length, right? Now the perpendicular altitude will be bisecting the base and the side will be 1. So now we have a triangle whose hypotenuse is 2 and the adjacent side is 1. Let me label this as ABC. What is B to C? Well, in this case, if I say that AB is 2, then AC will be half of 2. How about BC? Well, BC will be hypotenuse square minus 1 square root, applying the Pythagorean theorem, right? Which is 4 minus 1 square root 3. So this side is square root 3. Do you see that? So that becomes a special triangle in which the side lengths are smaller sides 1 and square root 3 and the hypotenuse being 2. Now, can you write down what is sine of 60? Sine of 60 means opposite over hypotenuse, which is equal to square root 3 over 2. Makes sense, right? Let's write down what is cos of 60. Well, cos of 60 degrees should be 1 over 2. And tan of 60 will be equal to square root 3 over 1, which is square root 3. Makes sense, right? So, in this special triangle, which is 60-degree triangle, right triangle, the angles are 60, 30, 90. The sides are 1, 2, and square root 3. We can find the ratios. Perfect. Now, let's look from the other side, which is from the side of 30 degrees, right? So, let's go to a fresh page and look at from 30 degrees. Okay. Sides 1 to square root 3 with right angle at C, right? Okay, great. Can you now write down the values for sine of 30 degrees, cos of 30 degrees, and tan of 30 degrees? Well, sine 30 should be opposite side over hypotenuse, which is half, 1 over 2. Cos will be adjacent square root 3 over hypotenuse, and tan opposite over adjacent, which is 1 over square root 3. We may rationalize this and rewrite this as square root 3 over 3. That's perfect. So, well, here we get the values for sine, cosine, and tangent. Perfect. Now, you need to verify that tan 30 equals to sine 30 over cos 30. Correct? Similarly, in the previous two cases, you could verify that sine of 60 is, tan of 60 is sine 60 over cos 60. Correct. So I hope so far things are very clear. We discussed about right angle triangle. Now, we'll also discuss how do we find these trigonometric ratios when a point is given on a coordinate plane. So we'll consider a point P which is 724. So let's say this is our coordinate plane. So I'm just making coordinate 1 slightly bigger. Point 7 and let's say 24 is right there. So this is point P whose coordinates are 7 and 24. It means that if I drop the perpendicular along the x-axis, this will be 7, and along the y-axis, this is 24. Now, if I am going to join the origin with the point O, we see we have a right angle triangle. So let us call this perpendicular at M. In that case, we have a right angle triangle OMP, right? So the triangle OMP is right triangle. Perfect. In which, what is OM? OM is equal to 7 and M to P is equal to 24. We can find OP also, right? So OP will be square root of 7 square plus 24 square. You can use the calculator and find this value. It is a special triangle with integer values, hypotenuse being 25. Great. So we know that this side as calculated will be 25. And now we can write down what is sine of angle O, right? Sometimes we write like this, angle POM. So what is sine of angle POM? Well, sine of angle POM will be the opposite side of 24 and hypotenuse of 25, correct? Can you write down what is cos of angle? Let's say OPM. OPM means this angle. As you see, adjacent side is again 24, right? So this is also 24 over 25. So what we notice here is that sine of POM is same as cos of OPM. It is also a very important thing to understand. They are called co-function identity. Basically, the other angle is 90 minus theta. Perfect. Now let's find what is tan of POM, right? Sometimes we write like this POM and the dot on O, saying that we are interested in this angle, right? This angle, POM. So tan opposite over adjacent gives us 24 over 7. Now for a line, 24 over 7 is also the slope of the line. So this value, tan of an angle for a line with x-axis, this is x-axis, is also the slope, right? So what we have just done is related trigonometric ratios with algebra, linear algebra, right? So slope of a line is also equals to, let me read out, m, the slope of a line, is equal to tan of the angle, let's say theta, which is rise over run. So in a way, all things are connected. And with this first lesson on understanding basic trigonometry in a right angle triangle helps you to connect so many things, right? A triangle with angles and sides. We converted these angles and sides into ratios called trigonometric ratios, sine, cosine, and tangent. Perfect. As you can see. And important thing was we just considered a right angle triangle, right? You will be thinking, why just a right angle triangle? Well, let's say we have a triangle which is not a right angle triangle, right? Let's say in that case, it can be divided into right angle triangles, two of them. If you understand a right angle triangle, you can actually solve any triangle for that matter. And that is what we are going to see in coming videos, how any triangle can be solved, how any point on the coordinate plane can be resolved into sine and cosine. And there onwards, we'll see numerous applications of trigonometry. So I hope you have enjoyed this journey of understanding what sine, cosine, tangent are, how do we use them, and a bit about special triangles, three types which we consider. And in those triangles, what are the values for sine, cosine, and tan for the given angles of 45, 30, and 60 degrees? With that, we come to an end of this particular video. Explore further to master these strategies on trigonometry. I hope you enjoy this journey. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.